2.3 Venn diagrams and set operations. So, Venn diagrams, we already know what they are. We have used them countless of times in English, but there might be something you don't know. Venn diagrams are actually from math. Because of math, it's why we have Venn diagrams now. So, math is super duper important. I mean, I know you guys get why it's important. I get it. You don't have to love it, but at least appreciate it, you know? Anyways, Venn diagram is a useful technique for illustrating set relationships. It's named for John Venn, no duh. Venn invented and used them to illustrate ideas in his text on symbolic logic. A rectangle usually represents the universal set U. The items inside the rectangle may be divided into subsets of U and are represented by circles. The circle labeled A represents set A. So this picture, the universal set is the box, and circle A, that means set A. So disjoint sets. Two sets which have no elements in common are said to be disjoint. The intersection of disjoint sets is the empty set. There are no elements in common since there are no overlapping area between the two circles. So picture we're in our classroom, and the classroom is the universal set. So all of our data and every question we're going to ask can only be asked to our classroom. So if we're in our classroom, something that could be disjoint is, let's say, has to be a good example. Hypothetically, let's say people who own a car and don't own a car. So I would give the question, who owns their car? And then you would ask, right? So if you own a car, do you have anything in common with someone who doesn't own a car? And just that question, no. So you're disjoint. It's either you own the car or you don't own the car. Not, have you been in a car? That's a different story. Proper subsets. So if set A is a proper subset of set B, then circle A is completely inside of B. So if you have a proper subset, A goes inside B. Equal sets, A and B are the same thing. Overlapping sets, that's the one we're used to seeing. So two sets, A and B, with some elements in common, that is called overlapping sets. So if I pose the question of overlapping sets for this classroom, let's say age groups. So we have, let's say what we break it down. No, age groups is not that good. Overlapping sets, let me break it down easier, of favorite color. So say your favorite color is green, but then we break it down into the original colors. So what creates green is yellow and blue. So say we have yellow and blue, it creates green, so green is the overlapping. Complement of sets. The complement of set A, symbolized A with a little apostrophe, is the set of all elements in the universal set that are not in set A. I'll talk more about that when we get to it. Not right now. All right, example 1. So we're given the universal set A, B, C, D, E, F, G, and set A, which is A, C, E. We're going to determine the complement of A and illustrate the relationship among sets U, A, and complement of A in a Venn diagram. So first things first, draw the Venn diagram. So how we draw the Venn diagram is we start off with a box. This is probably one of the only differences between math and English, is that you may not have ever used the universal box. So we label that U. Then we have set A. So in A, in circle A, which is set A, we have A, C, and E. So you see how we used A, C, and E? I like to cancel it out. We already used it. So everything else is B, D, F, and G. Those do not belong in A because A only consists of A, C, and E. So the complement of A, what that is asking so the complement of A is all the elements in the universal set that are not in set A. So the ones that are not in set A are B, D, F, G. So the complement of A, which is what's not in A, is set B, D, F, G. So it's asking what's not in the circle of A. That's what it's asking. What's not in that circle. Intersection. The intersection of sets A and B, symbolized A upside down U, B, is the set containing all elements that are in common to both sets A and B. So what they have in common, that's called intersection. So let's find the intersection of sets, and we're going to be doing a bunch of examples for that. So first things first, let's go ahead and draw our Venn diagram. It's a good place to start. It's actually not a bad box. I'm proud of that one. All right, so we have the universal set. We have set A, set B, and set C. So we're going to draw 3 circles. We have set A, so circle A, set B, so circle B. I'm terrible at that. And then set C, which is circle C. I drew C really small because there's nothing inside of it. See, it's just an empty set, so there's nothing in it. So we have to work backwards. Since there is nothing in C, I don't care about it. So let's look at A and B. A and B, that's this part right here. That's A and B. So inside A and B together, they have 1, 3, and 8. That's what they have in common. So since we already used 1, 3, and 8, let's take it out of the universal set. 1, 3, and 8. Now that A, B, and C, there's nothing more in common. Let's just write what we have left over. So in A, we have 2. So since we used 2, I'm going to take it out of the universal set. And for B, we have 6 and 7. And since we used 6 and 7, let's take it out of the universal set. Everything that we did not use that has not been crossed out of view goes inside the box. So we have 4, 5, 9, 10. So we drew our Venn diagram. Now part A. A wants us to find the intersection between A and B. So what this is asking is A intersection B. And intersection is in common. So A intersection with B, what they have in common is set 1, 3, 8. Because that's what they have in common. That's where set A and set B meet. Alrighty. Part B. Part B is the intersection of A and C. A and C have nothing in common. A and C, what it's talking about is right here. A and C. They have nothing in common there. So what we say is empty set, or that little circle with a line through it. Jeez, I want to get it in the middle. There we go. Best as I can do. So there's nothing in common. Alrighty, part C. Part C is asking the complement of A intersection with B. So what it's actually asking is not in A, in common with B. So what's not in A, but that is in common with B? So first things first, let's find what not A is. So the complement of A is what is not inside A. So every single number that's not inside A. Not inside A. So inside A, we have 1, 2, 3, and 8. So every single other number that's not inside that green bubble, the bluish green bubble, is 4, 5, 6, 7, 9, 10. That's everything that's not in A. So now that we know what is not in A, what does it have in common with B? So B is 6 and 7. So that's the only thing in common that it has, 6 and 7. So the complement of A intersection with B is 6 and 7. Alrighty, part D, I'll do up here. Part D is the intersection of A and B, but not that. So what is that actually asking? Sorry, my bad. What's in? So what it's asking is what's in the universal set that's not in the intersection of A and B. So we actually have the intersection of A and B. We did that already. Remember in part A, it's 1, 3, and 8. So 1, 3, and 8, just take that out of the universal set. So look at the universal set and use every single number but 1, 3, and 8. So the complement of the intersection of A and B is everything that's not 1, 3, and 8, which is 2, 4, 5, 6, 7, 9, 10. So intersection, remember, that's what they have in common, intersection. Because if you're intersecting, that's where all the roads meet. That's where they all have in common, that intersection. All right, union. Union of sets A and B, symbolized AUB, is the set containing all the elements that are members of set A or set B or of both sets. So when you union something, think of marriage. Marriage is the union between two people. So union means you're combining, you put together, you mush together to become one. That is a Spice Girls song, and I am quoting that. I hope you know that. If you don't know what it is, look it up. It's a great song. The music video is ridiculous. All right, so example 3, the union of sets. So we're given the union, or the universal set. The universal set is 1 through 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, those are natural numbers, aka counting numbers. And we're given set A is 1, 2, 4, 6, set B is 1, 3, 6, 7, 9, and set C is nothing. So we're going to start off by drawing our set as a Venn diagram. Do you absolutely have to draw a Venn diagram? Nope, we don't. I just like pictures. I'm a picture person. So I'm drawing it because I need to see it, and some of you may need to see it. But if you don't need to see it and you can get it without drawing the circles, by all means, do it. So we have our universal set. Then we have set A, so set A. Then we have set B. Then we have set C. Since there's nothing inside of it, I don't care, it's just a little tiny circle I put there. All right, now we work backwards. Let's figure out, what do A and B have in common? So they have 1 in common. They have 6 in common. And that's it. So remember, we used 1 and 6, so take it out of the universal set. Now, since nothing else is in common, we're just going to write what's left over. So in A, we have 2 and 4. And don't forget, cancel 2 and 4 out of the universal set. And in B, we have 3, 7, 9. And don't forget to take those out of the universal set. And everything else gets put in the U, the box, which is 5, 8, and 10. And I got those here, here, and here. Now that we have our pretty picture, let's go ahead and start working these out. So we want to know, if we smush together A and B, so if we union A and B, if we mush it together, everything that's inside A and inside B. So everything inside of the green circle and the purple circle. So we have 1, 2, 3, 4, 6, 7, and 9. Everything that was in A, everything that's inside B. We put it together, we get 1, 2, 3, 4, 6, 7, 9. All right, B. We want to do A union C. So if we put A and C together, I don't care if there's nothing inside C. That just means we don't have to add anything. So everything that's inside of A, everything that's inside of C, it's 1, 2, 4, 6. Technically, that is everything inside of A and inside of C. You don't have to put an empty set. It's known that it's there. It's just like how, there's always a 1 in front of a variable, but we never put it. We just put x. We never put 1x. It's the same thing. We never put the empty set. Alrighty, part B. My bad. We did that. Part C. So we're asking the complement of A union B. So not in A, union B. So let's figure out what's not in A. So what's not in the circle of A? So everything that is not in A is 3, 5, 7, 8, 9, 10. That's everything that's not in A. So now let's union it with B. So if we mush everything we just figured out and put it together with B, we have 1, 3, 5, 6, 7, 8, 9, 10. Alrighty, part D. So we're asking for the complement of the union of A and B. So that means everything that's not in the union of A and B. So first things first, we know the union of A and B. We found it. It's 1, 2, 3, 4, 6, 7, 9. So everything else that's in the universal set that is not 1, 2, 3, 4, 6, 7, 9, that's 5, 8, and 10. The meaning of and or. The word and is generally interpreted to mean intersection. The word or is generally interpreted to mean union. And this part right here is just saying x such that x is an element of A and x is an element of B. That's all that's saying. The relationship between the number of elements of the union. So to find the number of elements in the union of two sets A and B, we add the number of elements in set A and B and then subtract the number of elements common to both sides. So for any finite set A and B, the number of elements of the union of A and B equals number of elements of A plus number of elements in B minus the number of elements in A intersection B. And we're going to use that formula. I'll show you how easy it is to use. That you don't even need to memorize it. You'll just know to use it. So how many visitors speak Spanish or French? So the results of a survey of visitors at the Grand Canyon showed that 25 speak Spanish, 14 speak French, and 4 speak both Spanish and French. How many speak Spanish or French? So I want to know who just speaks Spanish and who just speaks French. So we're going to technically use this formula, but I'm going to show you that we really don't need to use it, okay? So to find the or, remember or is the union. That's what or means. So we need to know the number of each. So A, we can say A is Spanish. So how many speak Spanish? 25. We can say B is French, and 14 speak French. And then this part right here is both. So how many speak both? Well, they said 4 speak both. So we just put them in order and we subtract. So number of A, which is 25, plus number of B, which is 14, minus what they have in common, so 4, because both speak 4, and we get I don't know why I said 35. I was going to put 19, my bad. It's 35. I was looking at all the wrong numbers. So it's the number of the whatever you designate A to be, which is 25, and then it's adding to the number of whatever you designate B to be, which is 14, and then we need to subtract that from how many speak both, which is 35. All right, difference of two sets. The difference of two sets, we'll talk way more about applications of sets in the next coming chapters, or sections. The difference of two sets A and B, symbolized capital A minus capital B, is the set of elements that belong to set A but not to set B. So region 1 represents the difference of the two sets. Using set builder notation, the difference between two sets, A and B, is indicated by the set of A minus set B equals x such that x is an element of A and x is not an element of B. So let's do that. We're not going to draw a Venn diagram here because we're subtracting sets. So part A. Part A wants us to subtract sets A and B. So what that is saying what this is asking is the set of elements that are in set A but not in set B. So what they don't have in common. So A and B, they have B in common they have D in common, and they have H in common. So you see what's left over? E, F, G. That's the set. E, F, G. Part B wants us to do A minus C. So what that is asking it's the set that are in A but not in C. So in A and C, what they have in common is B, E, and G. So everything else, my bad, everything else is what is left over. So A, E, and, my bad, why did I say A? B, E, and I canceled out the wrong one. My bad. Let's start over. I was canceling out the wrong ones. All right, so what they have in common is B, E, and G. What's left over is D, F, and H. Part C. So what's the complement of A minus set B? So first, we need to find the complement of A. So what's in the universal set that's not in A? So B they have in common, D they have in common, E they have in common, F, G, and H. So everything else is not in A. So A, C, I, J, and K. All right. Now we want to take that away from B. So I'm going to rewrite set B here. So what they have in common is A, J, and that's it. Okay, sorry. I wrote down my B wrong. And I realized that. I'm not going to edit these videos because that just takes forever. It takes about start to finish 5 to 8 hours if I'm editing and stuff like that. And since this is just special circumstances, I'm not editing these. So let me rewrite B. Maybe you caught it, maybe you didn't. That's fine. Took me a minute. There we go. That's B. Now let's cancel out what they have in common. A and and J. Oh nope, that's it. Did I miss something again? I. There we go. There we go. My bad. We'll get there. We always do. So, the complement of A minus B equals what's left over. C, J, and K. Only what's left over in A because that's the first letter. My bad. My Bixby went off. It's basically Siri for Samsung. So we have C, J, and K. Holy cow. We got there. We got there. That's all that matters. All right. Going on to part D. Did I have a part D in this? I did. Okay, just making sure. Alrighty, part D. All right, so part D, we want A minus, so set A minus the complement of set C. So what it's asking is the set of elements that are in set A but not in set C. So first things first, we always need to figure out like what that complement is. So if they're talking about complements, let's figure it out. So the complement of C is whatever's in C in the universal set, cancel those out, and what's left over. So in C in the universal set, we have B, E, and G. So everything else is the complement. So everything else left in the universal set is A, C, D, F, H, I, J, and K. All right, so now we need to take A and subtract it to our C. So let me rewrite what A is. All right, so that's A. Now let's cancel some stuff out. So they have D in common, F, and H. So everything that's left in A. Why what's left in A? Because that's the first letter. So everything left in A is B, E, and G. Alrighty. Cartesian product. So the Cartesian product of set A and B, symbolized A times B, is read A cross B. See how I got you there? Because we would have read that A times B, but it's actually called A cross B. And it's the set of all possible ordered pairs in the form AB, where A is an element of A and B is an element of B. So A is an element of set A and B is an element of set B. Ordered pairs in Cartesian product, so select the first element of set A and form an ordered pair with each element of set B, then select the second element of set A and form an ordered pair with each element of set B. Continue in this manner until you have used each element in set A. So I'll show you what that means. The Cartesian product of two sets. So given set A is orange, banana, apple, and set B is 1, 2. So let's do part A. Part A is A cross B. So it is A times B. So it's a set. So you pair them each together. So what that means is we have orange with 1, and then orange with 2. And that's it for the oranges and for A and B. Now we move on to banana 1 and banana 2. So that's all we can pair from A to B. Now we do apple 1 and apple 2. And that's A cross B. So we're just putting each part of A with B. So orange with 1, orange with 2, banana with 1, banana with 2, apple with 1, apple with 2. Now let's do B cross A. So we're looking from B then to A. So we have 1 orange, 1 banana, and 1 apple. Not bad. And then we have, so we did 1 orange, 1 banana, 1 apple. Now we can do 2 orange, 2 banana, 2 apple. So 2 orange, 2 banana, and 2 apple. Alrighty, part C. Part C is a little long. Alright. So A cross A. That means we're putting A together, like in itself. So we have to do orange, orange, orange banana, orange apple. And let me rewrite A twice. That'll help us out. All right. So we're doing each to each. So orange, 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 banana, orange, apple, banana, orange, banana, 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 apple, apple, orange, apple, banana, apple, apple. So orange, 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 banana. I'm going to do OB. And then orange, apple. So I'll do OA. I won't be lazy. I'll write it out. And then orange, apple. Now we do banana, orange. Banana, banana. That's so fun to say. And then banana, apple. Then we do apple, orange. Apple, banana. And then apple, apple. And there's our set for A times A. Or A cross A. But you know what we're talking about. Alrighty, part D. B cross B. So I'm going to rewrite B twice. Where's it go? 1, 1. 1, 2. 2, 1. And 2, 2. Another fun thing to say. And that's it.